Hey all, so we're going to talk today about simplifying and evaluating with imaginary numbers, which is going to lead us into complex numbers. So let's start by defining what imaginary numbers are. Get yourself all ready for notes, get everything squared away, and we're going to get started. So imaginary numbers are always of the form something times I, where the number b is what we call, it's an element of the real numbers, which just means that it's any number on the number line, if you remember from previous classes. And hopefully everyone remembers the definition that I is equal to the square root of -1. Now, one thing that's super helpful with evaluating with imaginary numbers is that powers of I, as we can see here, simplify really easily. And the idea comes from, if we remember, I to the first, right, which we just read as I squared is the square root squared, cancels out. So I squared is -1. With those two facts, we can do a lot of simplifying. So for example, I to the third would be I squared times I, using our rules of exponents, so that's -I. I to the fourth is I squared times I squared, which is -1 times -1, which is 1. And with these four basics, you can just keep building up. So if I'm looking at my problems here, in number 1, it says I to the 7th. Well, I to the 7th would be I to the 4th times I to the 3rd, again using our laws of exponents. I to the 4th is 1, I to the 3rd is -I, and so I to the 7th is just -I. So any power of I is going to be one of these four terms. And it's just about using those to figure out exactly which ones. As they get bigger, I like to look for multiples of 4 because that's just going to always cancel out as 1. So if I'm looking at I to the 30th, I'm going to say, well, that's I to the 28th times I to the 2nd. And 28 is nice because then this is I to the 4th to the 7th times I squared. And anything that's to the 4th, as we said, is 1, and 1 to any power is 1. So this just becomes 1 times -1, -1. This will also work with your negative exponents. So what I like to do first here is turn it into the fraction. So take the line of the negative, turn it into the fraction. So 1 over I to the 5th. You can then simplify I to the 5th as I to the 4th times I. So that's 1 over I. And you can't leave it like this because I is a radical. Remember, this is the square root of -1 in the denominator. So in order to rationalize the denominator and have a final answer, we actually want to just multiply that by I, or square root of -1 on both sides. So then you have I in the numerator over I squared, which is I over -1, -I. As I said, it's only going to ever be those four terms as long as it's a power of I. Now, one thing that I do notice students do well is when I is written out as a letter. When it's written out as numbers like this, sometimes I see students make a mistake. So let's look at number 2 here. And with number 2, we have root -20 times root -125. And some of you will try to combine these together right away, and then you're actually going to miss out on your imaginary numbers. So I always recommend when you see a negative root, take out the I term first for both of these in this case, and then simplify. Because then you're going to get I squared. Root 20 is root 4 times 5, because remember you're looking for perfect squares like 4, or for the case of root 25 times 5. So 25 is a perfect square. Now you end up with I squared, I'll just write that as -1, times 2 root 5 times 5 root 5. So that becomes -1 times 10 for those, root 25 for the radical terms, which becomes -50. And if you tried to combine them right away, you would lose this negative. So be really careful with your negatives. I know this is how math always works. This is how math teachers always say. It's still important. All right. Now with complex numbers, these are numbers that are of the form a plus bi, where a and b are real numbers. So I'm going to use the same notation, just like that. And one thing that's really important about complex numbers is that every single number is a complex number. Some of them might have a 0 for a or b. A lot of them will. But all numbers are complex numbers. And this is a really important idea. Like whenever you have a number, whenever you have a complex number, you're always going to get an answer, unlike some of our other types of numbers. You'll always end up with an answer. You'll always end up with a simplified form. You're not going to end up with a DNE in any of these cases. So here, simplifying, when we're multiplying two complex numbers together like this, I will always recommend that you use FOIL as your method. So here we can FOIL it out and we end up with 15 minus 10i plus 6i, then minus 4i squared. And what you'll want to do first, just like we saw above, is the I squared, turn that into a -1. So usually what I'll do is just change the sign on that number. So then we have like terms, 15 plus 4 as our A term, as our real, not imaginary term, minus 10i plus 6i. So our final answer is 19 minus 4i. If you want to see that worked out with a little bit more work shown, you can feel free to look at the PDF in the notes. Another important operation is going to be division, just like we saw before. We have a root here in the denominator, so we want to multiply both the numerator and denominator by I. And it's really important that you remember to distribute that to both terms when you do that. So then we have 7i plus 3i squared over 4i squared. Just like before, I'm going to take that, just change the sign, change the sign. When we write our complex numbers, we want to write the real term first and the imaginary second. So what I might say then is -3 plus 7i over -4. And then what you'll often see is simplifying the negatives. So divide a -1 out of both sides, which will leave us with 3 minus 7i over 4, which is a lovely final answer. You could also have 3 over 4 minus 7 over 4i, which just keeps your A and B's a little bit separate and a little bit more organized. Both of these answers are just fine. Now, sometimes you're going to run into a division problem where you have addition and an I in the denominator. And hopefully you do remember this from previous classes. What you want to think about is the conjugate. Now, the conjugate is basically the same number. So if I have A plus BI, the conjugate would be A minus BI. Like that. So all we're doing is changing the sign inside the parentheses. And the reason that the conjugate is really helpful is that when you multiply them together, you'll end up with a real number because your I terms will cancel out. In this case, if we look at just in terms of A and B, if you FOIL out this, you get A squared minus ABI plus ABI minus B squared I squared. Just like before, cancel, change. And the imaginary terms in the center cancel out as well. So you end up with just A squared plus B squared. And that's just going to be a nice rule of thumb to have. Now, in this case, we definitely want to use the conjugate, and you'll use the conjugate for the denominator. So if we have 3 plus 5i over 1 minus 2i, we take the conjugate of the denominator, which is 1 plus 2i. Again, all we're changing is the sign in the middle. Multiply on both sides. And you're going to want to make sure that you FOIL these. So sometimes I'll add in my own parentheses like this, so that when I FOIL, I can simplify easily. In the top, we get 3 plus 6i plus 5i plus 10i squared over, and you can use the rule or you can multiply it out. I'm going to use the rule, 1 squared plus 2 squared. Then we can simplify here, make it a negative. And so then we've got 3 plus negative 10, negative 7 for our real component, plus 11i all over 5. Since 5 is positive, you can just leave it like this, or you can separate it out as negative 7/5 plus 11/5 I. Obviously, using decimals would also be fine. If you have questions about complex numbers, please be in touch. If you have questions about anything, please be in touch. And I look forward to talking to you soon.